Okay, so we are solving the problem 9 from Web Assigned for the chapter 2, which is problem 47 from Giancoli 6th edition. So what we have there is a stone that is thrown vertically upward with a certain speed from the edge of a cliff. Okay, so let's draw our cliff here. And this stone is being thrown upward, so that means it has an initial velocity different from zero. In the book, they give us the magnitude of this velocity is 12 meters per second. You see that I'm leaving a space here because I still don't know if I'll call this up, plus, or minus. We'll decide. We know that the height of this cliff is 70 meters. Okay, and that's all the information that is given. So let's try now to solve this problem. First thing we are going to do is to choose a reference frame. So this is a straight line along the vertical. So let's draw a straight line here. All right, so where are we going to call the origin in this straight line? A convenient position is to put it right here, right where the motion starts. By having this choice, we have then that the initial position is 0. Okay, now let's choose pointing down to be positive. Remember that this is completely arbitrary, but this is the choice that I made here. So if I made this choice, this means that this is point 0 and this is point plus 10 and then it's plus 20 all the way to plus 70 once we hit the ground. Okay, what else we know? Well, the cause for this motion is gravity, G, and G is always pointing down. Since my reference frame pointing down means positive, I know that G is plus 9.8 meters per second squared. Now that I made this choice for the reference frame, I am able to put a sign for this initial velocity. My initial velocity is pointing up, so up is negative. Okay, so now we can solve the problem. The first question is, how much later does it reach the bottom of the cliff? So how long it takes for the ball to show up at the bottom of the cliff, at the ground. You see that this is a question about time, and they are giving us the position. And this position, this final position here, is plus 70 meters. Okay? So best way to solve this question is by using this equation that connects position with time. Okay, and we have all of these symbols. We can substitute all of these symbols with numbers. The final position is 70 plus 70. The initial position is 0, so I'm not going to write 0 here. The initial velocity is minus 12 because it's pointing up. The time is what I want to find. A is the acceleration and is pointing down, and down is positive. Divided by 2, t squared. So this is the equation now that we have to solve to be able to get to the time. If you solve this quadratic equation, put it in your calculator, you will find two answers. One is minus 2.749 seconds. The other one is plus 5198 seconds. This one we discard because it's negative. Time cannot be negative. So this is the one that we are going to carry. So you see that the time is 5.20 seconds. Okay, so this is the answer for part A. How about part B? Part B is, what is the velocity that this ball has when it hits the ground? Okay, the question is about velocity, so let me go for an equation with velocity that can give me final velocity. So this is the best one because we do now have time, so I can just substitute this time here. The initial velocity we have is minus 12. The acceleration we have, so be very careful with the signs, but if you put it correctly, you should get that this final velocity is 38.9 meters per second. This is the magnitude, so if the question is just asking for the speed, this would be enough. If it is asking for velocity, so it's also asking for the direction, you can put a plus here, or if you prefer, you can just put the number and say it's pointing down. So this is good for the direction. Next question is the one about the total distance that this stone traveled. Okay, so now we have to think a little bit, because this height, this whole 70 meters that we have here is just the displacement. X0 is the initial position, x plus 70 is the final position. So the total displacement of this rock, or this stone, is 70. 70 pointing down. But we want to know the distance, and we know that before hitting the ground here, this stone goes up, then goes down, and then travels this 70. So we need to know how high it goes, how high above the cliff it goes. Okay, so the best way to find how high it goes above the cliff, now I have no information about time, so the best thing to do is to use this equation here, because this equation does not carry any information about time. What do I know about the velocity at the maximum height? Maximum height is when the object stops to then reverse its motion. So maximum height is 0. The initial velocity is at 12 minus 12, but I'm going to square, so it's going to be 144, plus 2. The acceleration is positive 9.8. And from here, I will go how high above the cliff this stone goes. So how high above the cliff. The value that you get for this point here is should be 7.35 meters. So the whole distance that this stone traveled will be what? 70 for the displacement. And then this 7.35, which is how high it went above the cliff, it also came down, so this twice. Add it all, and you get the total distance, 84.7